Welcome, everybody, to the American Space Museum. I'm Mark Marquette. So glad you joined us today to stay curious with our good friend and NASA structural engineer, Gary Allgire. Hello, Gary.
How you doing?
Great to see you, Gary. We have always enjoy your programs, as do all of our Stay Curious watchers out there. I'm sure they'll be chiming in here in just a minute
Okay.
with their hellos as I'm bringing up. There we are. Got us up there. Gary is going to do a program that you've wanted to do for some time, taking on the moon hoaxers.
Yes, correct. The moon hoaxers they've had all their theories over time have been debunked. A lot of them by the MythBusters on TV has debunked a lot of them. Unfortunately, there's one that still has never been debunked, and it's the most important one. And because if you debunk it, then all the other stuff falls apart.
Okay.
And that is that the NASA people and our contractors, when we were processing the Apollo 11, we knew from our testing that the hardware was not going to work. And that is the whole reason why we had to fake it, because we knew it would not work. So, and we were told we were paid large sums of money to keep quiet, and we had to sign papers that says if we ever divulged what we knew, is that we would be put in jail and our families would be bankrupt and all this stuff. So that was one of the theories that came out at the, because that's how you justify the rest all the other ones.
Gotcha.
And nobody in NASA has ever spoken up before. And so
Debunking the fact that you didn't sign any contracts.
We didn't sign any, and I didn't get any extra bonus in my paycheck.
Yeah.
From them. So
well, Gary's going to take us through the process of being a space worker, which you were for how many years?
33 years.
Counting Apollo and shuttle.
Apollo and shuttle. Then I did about a year of as a consultant, working for a consulting company, doing the same job that I was doing when I left NASA.
Well, Gary's got plenty of great stories to tell on 6 or 7 or maybe almost 10 episodes of Stay Curious, and his 30-some years is eclipsed by a few years by my partner, Marty Winkle, over there on our board. Marty, great to see you over there on the Streamlabs board today. We've been talking to Gary about doing this show for a while, haven't we? So we're looking forward to that. And Gary Gerald is here. No, is he on there yet? Nope, Gary Gerald's not on there yet. But my daughter is, and my granddaughter loves the candy in the background, just like I'm sure Mia does. Hi, Mia. Is with Grandpa up there in Michigan, and hello McKinley. She's there with my daughter Jessie in Bristol, Tennessee, and Macy's bopping around there somewhere with her big sister. So you've got a reason why you wanted this candy bracelet.
That's a candy bracelet that was very popular back in the 60s that young girls would put on there, and they had some that had actually letters on them, and you could rotate them around and make certain words or names. And I was talking to one of the engineers out at Downey one time I was visiting him, and he explained it to me. He came up and he says, "I've used this idea for something I used on the Apollo spacecraft." And later on in the program, we will find out where he used that design.
How a candy bracelet had something to do with the Apollo spacecraft. So stay tuned for that, kids and adults out there alike. As Gary's going to first talk about, we got Tommy Usiak saying hi to you. Steve Jokums is saying hello to Mark, Marty, Gary, and everyone in the Stay Curious gang from Lake County Spaceport in Fox Lake, Indiana. Steve, thank you so much for your support of us. We got Mitch Rothman. You're going to meet Rich. Mitch is going to be at our Christmas party tomorrow night.
Good.
I invited him to come do it. We're having our little employee volunteer Christmas party here at the museum tomorrow night. There's Gary Gerald saying hi to Gary Allgire there. And but we also want to kick this off with a little bit of the hold down bolts that a wonderful Mr. Daryl Higginbotham talked about. There is a Saturn V rocket. The hold down bolts are the one right in front of me, colored kind of turquoise. And this is where they are in the fire pit and the four corners. And though we got a great talk about what those were and how Mr. Dale Higginbotham was the engineer on those and how they worked, we were very unclear about where they attached to the Saturn V rocket. So Gary threw a few slides together for that. Yeah, Marty.
If you remember the picture I showed you that I took with the Saturn V,
Yes.
that had those yellow, I forget what you call them anyways. Anyway,
Metal
Yeah, like
extensions.
a flange, or flange. And it said yellow is usually GSE, so that would be it. But those yellow flanges are right where Gary is showing where the hold down bolts were.
Okay.
So they apparently replaced
I
that.
didn't have time to load that up, Marty, but we'll revisit it again. Steve Jokums also sent some information on that I didn't get to rack up. Gary brought those in as a little addition to today's program, where he's going to tell the truth about the Apollo lunar landings. But there's the hold down bolt things on the left. And Gary, take it away.
Okay, now to get back to, I'm going to be speaking about my career so I can debunk that all of us out there, had a job to do, and I'll go into that in a little more detail as we go through these slides. But this is the hold down post, and you had a question up there on the very above the man's head. There's a two looks like round cylinders there.
Yeah. Like
Now,
a punch or something.
like a punch. Actually, they're two separate things. And this concept here is not what was actually used. They used something different, but I don't know why, if this was a prototype or it was used on S1Bs over on pad 37 or 34. So,
Okay.
but we're going to go to the next one. This is the flight verification vehicle F500, I guess, is in the VAB being stacked. My first experience when I came here back in January of 1968 is that this Apollo 6 space, stack was in the VAB. It was in High Bay 1, I think. And then everything was on there, including the launch escape tower. And I was invited, I was the only one in my office that was invited. As a new engineer, I was really surprised to go out and watch the twang test.
Oh, this is a great story on
Yeah.
the twang test.
Now, where this picture was taken is exactly where I was standing for this test.
Wow.
And what they did is they, off to the right-hand side on that platform that's pulled back, they took a strap about this wide, and they took it out and they had put it around one of the legs and brought it back. And the object was there. What they were going to do is they pulled that strap and they took the tip of the launch escape tower and they pulled it over so it was over 1 foot. And then they released it. And they went like this and then came back, and that was it. Very stiff. But that was to calibrate the strain gauges in the hold down post.
Okay.
So
350 feet
yeah.
below are the hold down posts.
Yes.
And wow, that's the twang test.
That was the
That
twang
is
test.
the back and forth that you get.
It went. They pulled it over a foot, which was amazing to me because I didn't think that thing we could do that. And then it went over past vertical, about 3 or 4 inches past vertical, came back, went past vertical maybe an inch, and then back, and that was it. Very quick.
Now we think about the twang test of the shuttle stack, and that was inherent in the launch profile because the 3 SSMEs ignited, pushed the orbiter forward, and then when it leveled out, it came back, and then that's the moment they launched
T0
straight
was
up,
right there when it came back vertical.
Uh-huh.
But that was the twang test, and it was from when you look at it from that height, instead of the vehicle looking bigger, it actually looks smaller because it's so far down there. We're up about 500 feet.
Very cool, very cool. Well, more hold down bolt knowledge here.
Now
Gary.
can we blow this up? Yeah, there we go. The arrow points out, if you see that rectangular opening
Yes.
that it's pointing to, okay. And then where I have drawn the circle there, that is where the hold down post comes in and goes inside that opening.
Okay.
Okay.
See that, Marty? I believe that is where you had. He showed me pictures of the Saturn V out
Yeah.
there.
Now this is a siege three
So I
drawing.
interrupt there. The yellow part fits inside where you have the circle there.
Right.
Got it.
And that is a hold down. And this is a computer generated image, and the large looks like a plate. It's underneath the yellow thing. That is your strain gauge, or load cell. We would call it a load cell.
The disc there.
The
at the
disc
bottom.
is your load cell. So let's go to the next one. Now this one here, the gray part that you see was that yellow part in the previous picture. The yellow that you see is actually the Saturn V structure.
Okay.
Okay, and the blue thing is part of the hold down post. And
Okay.
then underneath that, you'll see a block, a plate. Okay, that has a pin in it, but what it does. It's bolted to.
There.
It's right there.
Okay.
Right there. Okay. And so that clamp comes in, and what it does is just holds that in place. So basically, it does not hold the Saturn V down. It just keeps it from moving.
All
Okay.
right.
So, because you got, at fully loaded, it's 6.5 million pounds. It's not going to go anywhere.
Yeah.
And I don't know what it was empty weight was, but that's what it did. It didn't actually physically clamp it down, but what it did, it just held it in place. And there was 4 of them.
Okay.
So that's how that worked.
Steve says he's never seen this in any books before, so he thanks you for that.
Okay.
And this is an interesting topic.
Yeah.
We've got.
Now this is Daryl talked about the studs that they would pull and send it through a die to control the first couple of inches of the motion. And what that is, that's circled there. Now, I've seen 2 configurations, one on each side of the hold down post, and I've also seen a configuration where 2 of them were on the same side.
Mm-hmm.
Okay, so we go to the next one here.
We want to say hi to John FL 142. Always good to see Gary. Thank you for watching, John. And Dean Babcock's watching, as is Cliff Watson has come on board here, and Carlton Bailey. It is a beautiful day to sit outside and watch the show, Carlton. We're having a nice Florida winter day here. The last couple days of fall, actually.
This is now this is the bolt. The light blue is the stud. It's tapered up inside to where it's inside the yellow housing, and it's connected. The upper yellow is connected actually to the Saturn V. And then the blue is connected to the hold down post. So as it lifts off, it will deform that the light blue, and so it'll pull it apart. But the yellow stays and flies with the Saturn V. It'll be hanging out underneath.
When it gets enough thrust, it's like bigger at the bottom and pulls out through there.
Yeah, and it goes through a die.
Mr. Higginbotham did have that to show us too.
And we used that concept on Apollo 15 on something.
Oh, okay.
Yeah.
All right. Well, we'll talk about that later one day, I'm sure. Yeah. Oh, and let's see. We got another. Yeah, we still got.
Okay.
This
just shows where
where this is, right?
Yeah, it just shows where it's connected. It's actually up underneath the skirt there a little bit.
Okay. So you got your Saturn V is the structure here. There's the familiar side pods, and there's the structure that Mr. Higginbotham talked about.
And this shows the cord that he talked about, tied from the Saturn V and then over to the hood, and so it pulled it shut as it lifted off the pad.
This is the hood to cover up everything from the flames, and they had
it's a backup, really, if in case
he had some Sears and Roebuck rope that they bought there, and that's the Saturn V vehicle on the side there. So. Yeah. Of course, we loved, if you go back there and see that, this whole mechanism had an elbow joint, an elbow at the end that ricochets back, and the absorption was dampened out by a piece of oak wood out of a tree trunk, oak tree trunk. And because that hood didn't close on 11, it got scorched, and he had a piece of wood from that. Marty, you got a question there?
Yeah, a question from Mitch Rothman. How big around is that blue structure? That's on a previous slide.
The blue structure. Now that
Go back one more.
that I don't know what the diameter was.
So you get an idea
yeah,
there.
it's maybe
Half a foot. Not too
that's the
big.
length. That's I would say he's there actually, but the diameter. So the diameter is probably an inch diameter, or maybe an inch and a quarter, maybe.
Oh, so not that big.
Yeah, it's not not really big.
Well, you see the structure with the hood on it,
Yeah.
and in comparison, we've got a person. There it is
Yeah.
there, but you got a person lined up there.
Yeah.
So, on the left. So, well, thanks, Gary. Thanks for your question, Mitch. Be good to see you tomorrow and come and join our party. You're certainly becoming a valuable partner of our museum. Marty's got a question here for everybody.
Let me get out of the way.
Oh, you're good. I'll make it small there.
Okay.
I wanted to put my glasses on. Okay. What was used to open the Saturn lunar adapter, the slot, for the Saturn V to expose the lunar module to space and to the command module?
Great questions. They take this lunar module apart and lost part of the command module during our hurricane prep. Glad that's not over. There's your third stage, and the lunar module is in the Saturn lunar adapter. And Marty's been inside of that thing while it was on the pad many times. Huh?
Saturn LEM adapter.
Saturn LEM adapter.
Spacecraft.
adapter?
No, it's spacecraft and lunar adapter SLAW.
And everybody has their own spacecraft lunar adapter.
Spacecraft.
Saturn LEM adapter. But it's the SLA in the vernacular. You say it's the Saturn.
Saturn to launch to SLA. Saturn to lunar module adapter.
4 panels. Marty's actually been inside of that, working on the pad, changing batteries or something like that. Marty, you told me, right?
Well, did a lot of things.
They did a lot of things
Thank
in
you.
there. Okay. And did you ever take a nap in there while I was on the pad, waiting for someone to check your work?
Never.
Never.
No.
Did you ever get caught in a storm inside of it on the pad?
Oh, somebody got caught in storms, and that, you're talking about twang. Well, that Saturn V twangs, and you can certainly feel it at that 320-foot level.
Wow,
Yeah.
you feel it going back and forth like that.
Yeah, I was in a
That's
hurry to get out of
300.
there.
Pardon me?
I was in a hurry to get out of there.
Yeah, but you had the criteria that you probably had to stay there because of lightning or whatever, right? So this is at the 320-foot level. You said about that, and when the command module separates, it comes around the dock and bring out the lunar module, but they got to get rid of these pedals, these 4 pedals. So how did they do that? All right, everybody, and so offer your question, your answer there, and we'll tell. That'll be the last thing we do today here. So, great question, Marty. Thank you. All right, my friend, I'm turning it over to you. You tell me when to. Steve Jokums, of course, he's going to guess springs, pyrotechnic bolts, and keep guessing.
Yep.
All right, keep guessing.
It's a hard one.
All right. Beautiful hypergolic launch of that Titan rocket.
Okay, this is for us to go to the moon. When John F. Kennedy, President Kennedy, announced they were going to go to the moon by the end of the decade, the Gemini program was established to do certain things that once if we could do, then we can prove that we could go to the moon. And so that's what the Gemini program was. This is Gemini 10, and right behind it, you'll see back there on the pad 39A is the flight verification vehicle when it was taken out to the pad for
500F.
Yeah. So that's we were well on our way during the Gemini program for the Kennedy Space Center and the development of hardware and getting ready for the.
Oh, the hardware was in the pipeline.
Yeah,
for 3 years before the first
Yeah.
for all the missions. And to think of fit check that you're saying, think of Enterprise in the shuttle.
Yeah.
The Enterprise was a although it flew and this one didn't. It was sort of a fit check model for everything, and you can tell by the black line beneath the command module.
Yeah, what they're doing is they're fit checking and swing arms out at the pads and some of the electrical connections, and then getting data from a wind standpoint to see, how much the wind affects that vehicle while it's out there. So quite a bit of work was done with the flight verification vehicle.
It's fascinating. Marty was inside that thing as a young man.
This is the first Gemini crew that was brought on board, because since Mercury was just a single astronaut flying, and we were going to be flying 2 at a time, they needed to bring in more astronauts. So this is the first of the 2 groups that were brought in, and this is the first group with Pete Conrad down on the lower right hand side. See.
Middle, you got Jim.
Got Jim
McDevitt's in the center. Lovell's on the left.
Elliot C.
lost his life.
Yeah, and then above him is Ed White, and then above him is Neil Armstrong, and then Frank Borman, John Young, and then Tom Stafford.
Yeah,
are the ones there.
Yeah, we lost.
Unfortunately, we lost Ed White, and we also lost Elliot C.
Right, but Ed White did get a flight.
Yeah, yes, he did. And then this is the second group of the astronauts that was brought on board. You got over on the left, that's, oh gosh darn, I can't think of his name.
Which left?
On the left side of the screen.
Well, top, you got Mike Collins.
Yeah.
And then below him is Buzz Aldrin.
Yeah, Buzz Aldrin, okay.
And then you got top left, the best flat top of any astronauts, Walt Cunningham. And then, who you got next to him?
That's, you see, he flew at Apollo 7. I think.
Oh, that Don Isley.
Don Isley.
Yeah. And then
you got
the center one. He passed away.
Yeah, that's Theodore Freeman.
Yeah.
And then you got Dick Gordon. You got Rusty Swiker, Dave Scott, and then over there you got Clifton Williams, who also lost his life.
And he was scheduled to go on Apollo 8.
Yes,
I believe.
It was.
And Anders replaced him.
Right. And then on the bottom, you got Cunningham behind my head.
Yeah,
And
you've got that's Gino. That's Gene Cernan.
That's Gene Cernan.
And of course, Roger Chaffee. And then
Alan Bean. And then that's
Bassett.
That's Bassett.
Charlie Bassett, who died with Elliot C. in a plane crash.
And that plane crash.
Anders, who we just lost this year.
Right. Now,
next to Buzz.
When Elliot C. and Charlie Bassett crashed into the building in St. Louis, that was the building my dad was working, and he was working that day.
Oh, really?
Yeah. And I asked him, because it came in, him and they were flying in formation with Tom Stafford and Wallace Schirra. And when they were flying into St. Louis, there was clouds came in, it started snowing. And then Tom Stafford lost sight of of Elliot C. when he went into the clouds. So he said he was going to come back around and make another approach into St. Louis. Elliot C. decided to continue on, and when he did, when he came out from under the clouds, he was right there at the building, and his wing clipped the building, and just put a small V into the building. It wasn't much, but they ended up in the parking lot, and they lost their life. And I asked my dad, I said, "Did you hear or feel anything that day?" And he's in the machine shop area, and he says, "No, I couldn't hear anything. I didn't really feel anything." But he was there that day when it happened.
Talked to several people. Jerry McDonald. I forget Jerry's name, was in that building too. Yeah. Well, there's Ed White's picture.
That was the first thing we did. We had to demonstrate that we could go and do a spacewalk. Of course, Alexei Leonov beat us by a couple of weeks or a month before we did ours. But this was Ed White's spacewalk, which was the GT4, Gemini 4, after Gus Grissom and who was Gus Grissom's partner.
The new 9 there, as I back up, is 2, 4, 6. That was the new 9. That was the 9.
9 there.
Jim Lovell's the only one alive of this group right there, of the new 9. That's sad but true. Yeah. And there we've got Rusty, Scott.
Rusty Swiker's still there.
Yeah, Rusty's alive. Yeah. Scott.
Dave Scott's alive.
Buzz. Oh my God, that's it.
Yeah.
That's it. 3 of those guys still alive. Wow. our heroes.
And then
Demonstrating here with Gary Allgire things that prove that we went to the moon. Why else would we be doing these things?
the next thing we wanted to do was actually do a docking test and dock with a Gina vehicle, but unfortunately the Atlas wasn't cooperating with us, and so when they GT6 when they were going to fly it, they had an abort on the pad, and so GT7 was scheduled for a 2-week schedule in orbit. So Mr. McDonnell from McDonnell Aircraft Corporation suggested to NASA that they would get GT6 ready to go again and rendezvous with the GT7s, which they did. So that was our first rendezvous. Also, I think this is 8 when John Young and Dave Scott were to dock with the Agena spacecraft that was
Neil
in orbit.
Armstrong and Dave
Oh yeah,
Scott.
excuse me, Neil Armstrong. And when they had the issue with the when they docked, it went into a roll. They thought it was the Agena rocket that had the problem. So when they undocked, it was actually in the McDonnell a Gemini spacecraft, and they did recover from it, but it did cost them to abort the mission.
But Armstrong's quick work probably got him the commander's seat on Apollo 11, and glad that he did.
And this is how they trained at the beginning: was they would sit in these cradles and they would simulate being in a 0G environment.
So this is horizontal. I don't have
Horizontal.
the slide in wrong.
No, it's horizontal, and then also they for Ed White when he was doing his spacewalk, they put him on a round plate with it was suspended on air. I mean, had air underneath of it. And
like air hockey.
Yeah, air hockey. So he would move around on that to simulate it. And the problem was, especially on Neil Armstrong's flight, is that Cunningham, I think, no, I'm sorry, I'm on the wrong one now. I'm on GT9 when Cunningham and Tom Stafford. We're all sure Tom Stafford. I could get him
GT9.
Yeah,
that was Cernan and Tom.
Cernan and Tom.
Stafford.
Cernan had to do a spacewalk where he had to go back into the backside of the spacecraft, and there was a backpack that he was supposed to get into and then fly around a little bit. To go back there, he got so overheated that his faceplate fogged up, started freezing up, and by the time they got him in, he almost passed away because of his heart rate got so high. And the next several missions, they had the same issues with overheating the astronauts when they did a spacewalk, and they were never able to complete those. And that was a major requirement. It wasn't until the last Gemini program flight with Buzz Aldrin when he decided, he says, he was a diver, he says, why don't we go into a pool and we'll practice in a pool. So NASA rented at a high school up in Baltimore, Maryland, rented that pool for a couple of weeks, and that's where he practiced.
Really, that's where they did it. Huh?
And that's where he did it, and he completed all 3 of the.
I think you got pictures of that here. Yeah. That we there's the recovery of GT8.
GT8
with that's Armstrong on the right and David Scott on the left, both future moonwalkers.
And what they did is we needed to learn how to land closer to the carrier. And what they established with Max Fouget, when he designed the capsule designs with the curvature of the heat shield the way it was, if you had an offset CG, what they do is they could steer that thing coming back through the atmosphere. And they could steer left or right by about 80 miles. And then they had a target where they could go almost like 300-mile range where they could go inside this box where they could do it. So that's how they were able to get closer to the carriers. And that was important for the Apollo programs.
Interesting.
Also on GT5, it was the first time we flew fuel cells.
Yeah.
That was important. So we developed those because we needed those for the moon program.
Instead of batteries.
They wouldn't have enough battery power.
Made energy out of H2O, basically.
Water and hydrogen.
Water and hydrogen.
Yes.
There is training water.
In water up in the pool. This is Buzz Aldrin here practicing going to the back end of the Gemini spacecraft to do some work, and he also had to do some stand-up work, but he was able to complete it all.
Yeah.
And that was the last mission that we did for the Gemini program. So now we
Did some tools and so forth.
yeah,
up
this
there?
was kind of a little joke as the astronauts like to do, and this is the Buzz and walking out with his partner there, and that's they put
Level.
the level, they put the in.
Yeah, on there. You know, Marty, what how you doing over there, Marty? You know, what always fascinates me about these spacesuits, they got the spacesuit right. These guys are walking around in them on Earth in training. I've seen High Hazel Banks, she's watching. When she was secretary to the Apollo astronauts, they'd be walking around the secretarial offices in their spacesuits to get used to them. You see them in the water, you know, you see them training. The spacesuit, I think it's just phenomenal. What do you think, Gary?
Well, they are, and they did a lot of development work to get to that point. You know,
I mean, they lived in them. They had such confidence in them.
Yeah.
They really did. I just admire how in all situations had their little cooling, you know, apparatus with them and all that.
That is the same way that we developed the hardware. There's a lot of what people don't realize that before you actually see it for the first time at the Kennedy Space Center, there's years of pre-development, years of development, going through different designs before they actually put it to actual usage.
Well, let's get to that. We just want to thank everyone for watching today, and I'll bet Mia and little Mia and my granddaughters are wondering what is the candy bracelet there in our background for, but Gary assured us this has something to do
We'll get to that
with
here
the
in a minute.
Apollo spacecraft. That you're gonna learn something from this great. He's a great engineer, but you have a great way of explaining the complex,
I'm a little
Gary.
nervous, but
And that's why we love having you on our show here. So let's get to the Apollo era.
this is it's hard to find one like this one because it does have Apollo 1 on it. Most of them don't have Apollo 1 that we were given at the time.
Yeah.
And that's unfortunate, but these are all the Apollo missions. That
I agree. They leave Apollo 1 off of all this thank you things that they give you space workers. And I really, I don't know why.
I don't know either, but anyways, but I just put that up there to introduce the
7
Apollo
at the
program.
top, 8 in the middle, then 9 go across like that to the
14,
final one
This is in the center at the bottom.
in the middle there. So,
This is our organization. At Kennedy Space Center, we had 3 major design groups. They were called divisions back in those days. We had the launch vehicle division, which all the engineers and technicians were stationed out at the VAB. There's office space in between all the bays in the VAB. I was in the space division, which is what we have here. There was 198 individuals in there, including our secretaries and so forth. Of the 198 people, we were divided into 6 branches with 17 we call sections.
6 across the top there. Okay, then your subsection.
Subsections of sections. So when I first came to Kennedy Space Center, I was given the option, when I was in the personnel office, to interview either the launch vehicle side or I could do the spacecraft vehicle side. And there was one other one I forgot, and that's design engineering was the other division. They were responsible for designing all the pads and the buildings that you see out there at Kennedy Space Center. But anyway, I interviewed my friend of ours when we came together. We decided we wanted to go to the spacecraft division. So that's all I interviewed. I didn't go to the launch vehicle. I went to a couple of the different sections and interviewed with the section chiefs. And then I ended up going into the mechanical section. And the section chief there was Harry Schoaf. And he was... Our division chief was Ted Sassine, and quite an interesting individual. But section chief, it's in the middle, right at the very top. If you come down,
There's Allgire.
Yeah,
Marty's.
You'll see Jimmy
He's
Handgartner
in the third column over,
third right.
below the second yellow bar is Terry's name. So I tell that McCrary beneath you there.
Yes.
I tell him a secret. Okay. How long's that secret gonna be kept among this 110 people
Well, you
here?
talked to the wrong person out there.
Oh, I did. Okay.
Whatever he learned, he never told anybody else.
Oh, all right.
In
Well,
fact,
I'm trying to get.
he
I'm,
and I-
I'm trying
he-
to get to a point there that nobody. There's old England over there.
Yeah.
Okay. Or beneath McCrary, there's Link or Steele.
Anywhere anybody else besides
Okay.
Craig McCrary, if you told him a secret or something, it would get through the whole organization pretty quick.
Yeah, so you're saying this is all fake here. We're just
No.
going through the motions here. We're really not going to
No.
the moon.
Well-
And that's our point: is how in the hell could you keep that a secret with these
Well, but
beautiful human beings
Yeah.
working their buns off?
Now, when I came here, Apollo 6 was in the VAB. Apollo 7 was, I think we may have been out at the pad 34, but I'm not really sure about that right now. But what I do want to explain, one thing before that, is that JSC was responsible for design and construction of the Apollo spacecraft. Marshall was responsibility for the launch vehicle, the Saturn V. Prior at each center, at least at JSC, they had people they called subsystem managers, and they were assigned with a specific subsystem, and they followed that from the very concept of it till it was produced and was put inside the spacecraft and then sent to Kennedy Space Center. We had an agreement with them, it was kind of a gentleman agreement, is JSC would do, once it clears the tower, that was their responsibility. But up until, as it arrives, until the point where we clear the tower, that's our responsibility. And they left us pretty much alone. Occasionally, we would have to contact them if we had a real bad issue that we couldn't resolve to see if we could get some of their subsystem managers involved and get it resolved for us. And then, so that's how that worked. But these guys, the subsystem managers, between all the testing that they experienced and all the testing that was done back at the companies, they generated a bunch of documentation that tells you how this thing is going to work. If it's electrical, it's got to measure certain voltages, amperages, and so forth. Motors, if they run, they have to time their motors to make sure that they time, because we know how long they should run to make this door open or whatever to do. So all that stuff is already given to us in a document. I don't remember the name of the document for the Apollo program, but the shuttle was OMRSD, Orbiter Maintenance Requirement Specification Document. That was our Bible. That's what everything, when the engineers wanted to write a procedure, they would pull that out, and that's what they had to do to make sure it met the steps that they were going to do would meet that requirement, and we would measure it. And if it did, then we moved on.
Mm-hmm.
So that's how it's done. But so that was a lot of pre-work that was done before we even got a hold of it. So, and our job is just to go ahead and put it in, install it, test it out, make sure it meets all the requirements, and then we can launch.
We're talking with Gary Allgire about the Apollo era, and we just had Apollo 17 splash down today or tomorrow, I think, after finalizing man's greatest adventure after 6 successful landings on there. Did you think back about it when you saw our posts and so forth that it was 52 years ago and no one's done it since?
I thought about it, but not too much. We
Okay.
have too many other issues at home right now health-wise.
All right. We know Sharon Rodriguez is enjoying that. Thank you, Sharon. She's out at the U.S. Space Force at the Sands History Museum taking care of that beautiful gift shop they have there. Sharon, thank you for supporting the American Space Museum in all the ways you do. Well, what we got here, Gary? Some beautiful...
This is the old... Well, back then, when I first started, it was the SOBs.
SOB. Now, wait a minute. Let's get this acronym straight there. Marty, he's swearing.
No, MSOB.
MSOB.
Well, it started out as SOB.
Okay.
Yeah, it started out as SOB, and for the Spacecraft Operations Building. I think I was there for 6 months before somebody in NASA figured out this is not a good name to have for this building.
SOB.
so they put an M in front of it for Manned Spacecraft Operations Building.
Like that changed anything.
Yeah. Well, when they put the man in front of it, it still didn't change anything. It took them about a year to figure this out. So then they finally made it to where we for the complete Apollo program and most of the shuttle program was the Operation and Checkout Building,
ONC.
ONC building,
And today it's called
Neil Armstrong Building.
named
So
after
it's-
this is the building where the astronauts lived.
Yeah.
The administrative people.
No, there's no administrative
No,
people.
not administrative. Okay, none there.
No, this is looking at it. This is from the north, looking south. There's three floors to it. The bottom floor, I think, was Grumman, and then the center floor was NASA Engineering, and the top floor was North American Aviation.
Go along with
At least,
that, Marty.
At least on the west wing. In the center was the administrative. On the second floor was we called Mahogany Row. That is where the launch director of Rockwell Patron was at.
Mahogany Row for their mahogany desks.
Well, the whole walls were mahogany.
Oh,
There was a
really?
group of offices there
Oh,
that
okay.
were all mahogany, and I don't know who was all of them. You know, Walter
Capron.
was his deputy, and then I guess George Page may have had one in there. And
Okay.
so, but anyway, that was a mahogany row, and then if you go to the next one, it's an aerial view. You'll see this, and then there's three walkways that cross over to the other half of this building that's behind us, and that has got a combination of offices, and this is where the astronauts lived. They were up right above my head over here. It was their that was where their living room was. I mean, where they could stay, and they had a kitchen there, and that's where they would do that. I don't know exactly where. Some in that area was also where they suited up. If you go down this hallway here, all the way down, that if you went past the center one right there, and if you went turning left, there was two doors you could go through, and those were many control rooms that give us that we used for testing the lunar module, and then also for the command service module was done in that area right there.
Marty, you're familiar with all that area?
Sure am. Yep.
Was that on? I kind of remember. Was that on floor 3 or was it 2?
Got a couple questions there.
For the
One
control
from Dean
rooms.
Babcock, Marty. Go ahead. Sorry, I'm interrupting these space workers.
Okay.
Okay, I had a question from Dean. Is the altitude chamber in the MSOB complex?
Yes, I was going to get ready to do that right now. As soon as I get my question made to Marty, is the two control rooms, one for the ACE, were they on the second floor or third floor?
I'm pretty sure they're on the second floor.
That's okay. That's what I thought, but I wasn't really sure. And in there, if you went into, there's another door right to there next to them. That way, if you went through it, you went into a little anteroom, and then from that anteroom, you went into the altitude chambers. And this is where we would change from a smock into a bunny suit if we were going to go inside the spacecraft. Now, this high area that you see here is called
the astronaut offices and stuff for this area here.
They're in this part of the building.
Oh, in the middle part. Okay,
Yeah, they're in the middle part, towards the west end over there.
All right.
Okay. Now, if you go a little further south, that is the high bay and low bay area. This is where we brought in the spacecraft. The two out. You can go back to the other.
And that
picture.
is over here to the far left.
I think it's got the circles on it. No, I guess not.
Yeah, I see the circles
Okay.
on it.
The two circles represent the two altitude chambers.
Oh, see that, Marty? Those two faint circles?
Yeah.
Your arrow's almost at them.
Yeah,
Yeah.
pointing to the whole area.
Yeah.
That's the high bay.
Okay.
Now,
Yeah.
the one on the right was for the lunar module, and the one on the left was the Apollo command module. And then to the left of that is where we would put the slaws, and we had another work stand in there for once we came out of the chamber to put the high gain antenna and the engine nozzle on. The low bay area was dedicated to almost all of it to the Grumman people for the processing of the lunar module. Now, the Apollo spacecraft came in this door right here, which is on the east end, when it came across from the skid strip on the Air Force base. And then on the other end of the building was a different door, and that's where the lunar modules would come in.
We got pictures of those.
Yeah.
Wait, here we go. There we go.
And stop there just a minute.
yeah.
Go back there in a minute. That crossway you see right there, closest to the end of the building, That is underneath there is where the astronauts always come out to go to the pad. So when you see those pictures coming out of the building, underneath there is where, and across from the other side of the building was where the photographers and some of the looky-loos would stay.
Familiar territory to Tommy Usiak.
Yeah, but that's where they came out.
I got
They still come out there today. And then
so they go, the bus goes to the right to go out to the pads, or over?
Well, the bus will.
I mean, yeah.
It will probably go straight down the road to the road, and then turn right on the road, and then out onto the parkway.
Yeah, the bus is right there.
Yeah, the bus is right there.
Okay.
So, and then right there below that, where his arrow is, where the 3 astronauts would always park their car. Well, next row over, rather. I'm sorry. And we never could park our cars there.
Yeah,
Now the
Corvettes.
door on the other low bay area is where the lunar modules would come in. They came in 2 boxes. They were flown in from Grumman, from New York, in a pregnant guppy, just like all the other spacecraft except for the stages.
Huh.
This is the picture of the altitude chambers. This is very late in the program because I don't remember them being white. They were always metal gray. But you had an entranceway in front of each one of these, and there's where we call the tear station. This is where all the documentation that we generated during the processing while they were in the O&C building. We had a quality control station where they had binders, and each binder was set up by system, and you could go in there and pull out a binder, and you could open up, and they would be all your back then it was discrepancy reports that we would, as engineers, we would review those and have to start disposition to fix that problem somehow or form another. And then we could close it out, and then it would go away to another area to be reviewed later in the process. This is Dr. Kurt Debus, who is the first center director. He is the father of the Kennedy Space Center, as far as I'm concerned. He was in charge of developing and laying out what Kennedy Space Center would look like. And he had a lot of background experience. He worked with Werner von Braun over in Germany, and he was Werner Braun's man whenever the pads were blown up from the rocket blowing up, or if the Allies found his pads and they blew them up, he was responsible for rebuilding those pads.
Okay.
So when he came over, von Braun put him in charge of the Kennedy
12
Space.
years as the director. Bob Cabana put in about a dozen years too as director there. Yeah. And both put their stamp on that space center for sure.
Yeah.
You see von Braun, you see Debus in a lot of the early launches.
He was always in the firing room. I had the opportunity, I was asked to go over and talk to him. He wanted to know about the docking system, the docking probe and drogue. And his office was in the headquarters building, and it's a 3-story building, but his office was on the 4th floor. Very nice, plush set of offices up there. And I run over there and sat down with him, with another gentleman that was an aide, to help him a little bit, because his English was still a little bit rough sometimes. And he brought out some coffee and some cookies, and I explained the docking system to him, and he enjoyed that. And I did invite him. I said, why don't you come over and I'll take you into the spacecraft? But he refused, and I really regretted that he refused.
Huh. Another Titan of the Apollo era.
Yes, this is Rocco Petrone. He was a feared man, let me tell you, at least by the contractors and some of the NASA people. He was a very stern person. He wanted to make sure us engineers, if he asked you a question and you didn't know it, you got your rear end handed to you. He was not shy about telling you what you need to be doing.
But if you tried to BS him, that was even worse.
That was even
fired
worse.
On the spot.
No, I don't know if he fired anybody. I don't. I've heard stories that if you BS'd him, he really got into you. I don't think he fired anybody unless somebody. I mean, to fire a NASA employee is hard. Let me tell you, it really is hard. We tried that one day in our office, and it didn't work out. But and I was tired of when I became a supervisor. I was told to fire a guy, and I couldn't do it.
Rocco Patron was over all the
He was the launch director.
launch director.
Yeah, and he was a very involved person. In fact, I had one contact with him on Apollo 8. We were having issues with the CSM umbilical buildup, and it was instead of taking a shift, it was taking about a week to do this. And so he came, and I was asked to go get with him. And so all the way down to get into the chamber, he asked what was going on, and I gave him my honest opinion. And when we got there, he looked at it, then he turned around and he gave me a little bit of a lecture because basically I was complaining about our quality inspectors because we have the framework was not bad, and hooking up the electrical connections and hooking up the fluid lines went smooth. It was putting all this cork around to enclose it out for flight. And it's for some reason cork, yeah. It's as an insulation, so when they're on orbit, of course, it's never going to re-enter, but the atmosphere. And so it was all the pieces didn't fit, and so we had to trim here, trim there. Well, as far as we're concerned, it's cut to match, paint to fit. I mean, cut to fit and paint to match. It's it's going to fit in there. They would stop us and say, no, you got to have an engineering order to show what you did. So that would slow the process down. And we just did that for on and on and on. And he lectured me. He says, I know it's an issue with these guys, but he says, you always listen to them, and you make them happy. You don't go any further than that. You got to resolve those issues. And he understood it. He said, okay, that's all I need to know. And away we went.
Rocco Patron, one of the Titans. He was a big man too.
He was a big, fearsome man, and they'd have meetings with big meetings with Tom O'Malley and him.
Tom O'Malley's test conductor.
Well, he actually was he was actually running. He was the manager for the Apollo program.
Okay.
For North American Aviation, and O'Malley is I don't know,
another difficult.
He's not difficult. I don't say he's not the smartest man on the earth.
Okay.
And he has a tendency to put his foot in his mouth, and people would beg to go in and be able to sit in that meeting and listen to Rocco Patron chew him out.
Oh yeah.
And make a fool out of him. It was horrible, but that was what was going on with the upper management, but.
I've had privileged a lot of conversations about some of these men. This was, to reset. This was the 1950s, 60s carryover, where women weren't even supposed to be in the workforce. No. Very chauvinistic world. You didn't have many women you were dealing with.
We only had one female engineer in the Apollo program, and she was in our office, Ann Montgomery.
Okay.
Was that, and she did very well over her career.
Joanne Morgan was in another area.
She was in a completely other building. She was in the com building, and I don't know about her engineering, what she did back then, but
so you're talking 1 out of 100.
1 out of 100,
employees is a woman, so very male dominated, and a lot of things that we don't do today, like yell at our employees that aren't underperforming.
You had to have a little bit of a thick skin because at any moment you could get if you went into a supervisor, and if you didn't do something right, and then the reaction is normally they give you a little bit of a lecture.
The bottom line was human lives were on the line. Just like our dear Mr. Darrell Higginbotham said that he worked on unmanned launches, but when there was people on it, he said he double, triple checked everything. Right, Marty? I see you got a question there, Marty. What is it on that UCAC family microphone?
Dean Babcock is asking, how long did tests in the altitude chambers usually last?
Well, they were never consistent. In fact, nothing was ever consistent. It could be 2 or 3, 4 months, 5 months maybe, in the chamber. I don't quite remember the exact time because they just went on and on and on. And then once you're out of there, and same thing in the VAB, they were there for maybe a month or two. And then we had that piece of paper here I showed you how long they were at the pads.
Oh yeah, right. He brought a really cool.
I don't know.
Well, we'll write that up one day. It's over
Yeah.
on my desk.
Oh,
I
it's
see
on
it
it,
later
yeah.
on my desk there. Of the
They were out there for months.
Yeah.
At the pad.
They were at the pad, but only 2 months about average though. Marty, go ahead.
Yeah, but all the tests in the altitude chambers would not run at altitude.
No, just the only altitude runs was you did one for the lunar module before it was mated and brought out of the building to go to the VAB. Same thing for the Apollo spacecraft. But all of this Apollo spacecraft, when it came to Kennedy, it immediately went into the altitude chamber, and it's where it stayed until it was time to go to the VAB. And so all of our testing and build up and was done inside the altitude chamber. Now the Grumman did their stuff outside the chamber, except the only time I know you went in there was where the altitude runs. Is that
Exactly,
correct?
but there was some preliminary tests that you had to run first. You had to hook everything up electrically.
Yeah.
So it has some prep type of tests.
Now we brought your lunar module. We took the ascent stage and turned it upside down, and we brought it over into our chamber, and then we lowered it down and docked with the command module. We did that for all of the Apollo missions, and then 2 of the Skylab missions, and then Apollo Soyuz test project.
So you turn it upside down to get all the change out of Marty's pocket that fell.
It didn't have
in
any.
there and the
There was-
washers and
I
stuff.
I'm not aware of any of that coming out. No, they did a good job.
Let's back up for somebody that might not know, what is the altitude chamber and what are you doing in there?
Altitude chamber was. We have a picture, I think, of us lowering it down in there, or is it later on? I don't know. It may not have it on this. Get my glasses on.
You may have some anyway.
Yeah. But there's a big ring in ours that the
Let's get on with this.
command module, service module sat on it, and that's where we started out. And then we would put the command module on it, and then we start hooking everything up, getting everything buttoned up, and then we start doing a bunch of testing on each system by one, and then we'll start doing integration testing. Bringing more and more components online until eventually we will do a complete end-to-end type testing, which is a lot of problems with our testing that we had to do, which was a lot of it. But
Okay. But they mimicked being in outer space too.
not until we did the altitude runs. That was, we brought the 3 crew people in, and they got in and closed the hatch, put the lid back on the chamber, got everybody out, and then we pumped it down to equivalent, I think, 70,000 feet. It was, or 170,000 feet altitude, and then they would go through a simulated launch, and also that was a verification that there was no leakage in the command module,
Okay.
and the same thing they would do on the lunar module.
All right.
And after we did that, then we were pretty much done, and we come out.
Thank you for that explanation. And we're going to have a long show today, but we're going to go through the images that we have here. Why is this candy bracelet part of the
Well, I have
Apollo
to move on.
spacecraft?
Oh, this is the mini control rooms that were behind the altitude chambers, and this is the office that I was in. They brought us over one day. Photographer came in and said, "Hey, all you guys go in here, and we're going to take your picture as though you're working there." We never were in this room, let me tell you.
You never were?
No, this is all for the
Is that you
fluid
in the
guys.
middle there?
That's
The
up me at the top. The next person down with the manual in his hands, that's John Fraley. To the left over here is Craig McCurry, and Jimmy Handgartner is the next one. Behind me is Bill Beaker, who became our section chief, and then the other one was John Link that we had in here. So those were the 3 lead engineers at the time. We ended up down to 2 when Bill Beaker became a section chief after Harry Schoaf retired. And this is a problem report off of the shuttle, but it's the same as what we had on the Apollo program. So back then they were called discrepancy reports. Okay. And this is the first box, big box that you have there is a description of what the problem was. And then the engineers would come back and we would go down on the lower box, large box. And this is where we would start doing troubleshooting steps, or we would do steps to correct the problem. Now, we were not, as engineers, allowed to touch the hardware. We were not allowed to tell the technicians how to do it. Everything had to be in writing. and then it was bought off. Once they did that step, then they had a special stamp that was attached to them, and permanently. I'm not physically, but they carried it around. It had a number on it that was associated with them. They would stamp it and said they completed it and date it, and then they would follow it up by a quality. First of all, would be the Rockwell quality or North American Aviation quality would stamp it, says I verified that he did it, and then there would be a NASA behind that that says I stamp it and identify. And they all had different stamps and they all had numbers on them. During the shuttle program, we did away with most of the NASA side of that equation.
Snoopy.
Yeah, this is Snoopy here. This was by the first ones were drawn by Ernie Rez. Let me get out of the way.
Yeah.
Ernie was actually started in our group.
Ernie Reyes, yes.
He was, but when I got there, he wasn't there. Ernie was in operations, and I couldn't tell you what his job was at all. All I know was he was the official tour guide.
He's like the ombudsman of Mr. Fix-It.
He would go around to all the offices, and he would go in and talk to the engineers, get all the information, and he kept that in his head. And then when he gave a tour to whoever it was, what dignitary or whatever, he was the guy that did it. And he was a very funny man. He had a lot of special words and stuff they could do. He was a delight. When he came into your office, everybody lit up because he was such a fun person.
Ernie's a great supporter of our museum and passed away during the COVID era. Yeah. We miss Ernie a lot. He's on a lot of the Apollo 50th anniversary documentaries and so forth. And his office on pad 34 was right outside the command module, Apollo 1. Yeah.
Anyway, he started out, and then it was taken over by a gentleman on one of the contractors.
But Snoopy would be on your reports and things like
that. This is a daily schedule.
Thing.
Every day at 2:30, they would have a scheduling meeting, and then in the morning you would go in and they would have the schedule printed. That was the first thing you did, is went in there and you checked the schedules and you grabbed the sheet. I have one here. I should have brought it out. It's about this wide. It's a pretty big size sheet. It covers 72 hours of work that's going to be done. And our job is to try to get on that schedule. And then the object of the Snoopy was to provide information. And also when people, unfortunately, when they did something funny and they screwed up, you made a Snoopy.
Yeah, you poked fun at him.
Yeah,
this is actually on Saturday, April 11th, 1970. That's Apollo 13.
Yeah.
Interesting.
Yeah. And this is the one, I made it.
That's your Snoopy.
That's my Snoopy. You can't see all of it.
But NASA regulations prohibit gambling on federal property.
Yeah.
I hope.
Well, what it was, I lost Nixon one time he took away all of the permits that us NASA people had. And so I was eligible for the draft. Then they came up with the lottery. And when they did the lottery drawing, I watched it and they pulled my name out on number 8. My birth date. So that's what they did. I'm referencing that as they didn't think that was a kind of a gambling type thing.
Cute.
And I ended up.
That's your birthday, September 4th. No, you're 8th.
No, I'm 8th. That was the eighth draw, and I ended up. I did get my draft notice, so I did go into the reserves. This is just the inner capsule of the Apollo spacecraft. It's made of 2 components. This is what the actual astronauts live in. You can see the tunnel up there at the top. And you can see how it comes down and then it drops straight vertically down. And then this is where the tanks, all the fuel tanks for the RCS and then oxygen tanks and so forth. Well, the oxygen tanks was inside. And this is what it shows with them 2 together right here. And then this is the makeup of the cross section of the 2 outer section heat shield and the inner side pressure vessel.
Heat shield, okay.
Yeah. If you start at the top, that's about I think, let me write this, I got these numbers down so I don't forget them. The inner heat shield was 1.5 1/4 to 1.5 inch thick.
So the spacecraft's up at the top where you see 70 to 150
yeah,
degrees.
where you see the 200 right there. And it's aluminum honeycomb. Then they have some felt fiber in between that they put to help keep the heat from being transferred from the next set that you see, which is stainless steel. And that was 1/2 to 2.5 inches thick. And then you had another, that's the inner one. And then you had another set of a honeycomb, which was filled with the ablative material. And that varied from 1/2 inch up to 2 inches in thick. And that's what burns away on re-entry.
Never seen that chart like that. That's very graphic.
Yeah.
So your heat shield interface is down here at the bottom
Yeah.
with the atmosphere, and you've actually got steel and fiber between that aluminum hull.
Yes. And this is Apollo 6. This is what it looks like after it's re-entered. This is on the hatch side, so it doesn't see quite the temperatures, but you can see how the ablative material has been eaten away. And this is all based on what Max Fouché came up with the design. He realized that if you have a very pointed object, the plasma that builds up around the skin actually it's moved away because of that. If you're flying down with a blunt object like that, it stays. And when it does, it gets to a max temperature of 5,000 degrees and it doesn't get any hotter than that. It'll burn away the outer section and then it starts all over again. And it goes all the way through. The Mercury spacecraft, this heat shield was a fiberglass, layers of fiberglass that would slowly burn off one after another. That's what they use for Mercury.
Ingenious.
Yeah. And this is that material that you see that they put in there to help protect the
insulation type of material.
here. This is a block 1 right here. And then this is next a little bit lower down. You can see that they don't have the insulation down in the lower area there, but that's where the oxidizer and the fuel tanks would be.
Okay, and
Oxygen tank would be inside. This is a layout of the interior with the couches, and we're going to get into the couches here real quick. The 3 couches sit in a frame, and they can be removed from those frames independently. Go back still, we're not ready yet. And up there you'll see the 3 sleeping bags that the astronauts could unroll and sleep in those. I don't know if they carry those on all the missions, because with Apollo 13 there's no reference that they ever used those when they were sleeping. So
okay. Let's go. The couches are the green.
Well, the couches are the gray, and this shows you the couches in the. This is the sleeping stations in the lunar module. One's sleeping on top of the engine, and the other one's up above across the deal. So that's
Windows are to the right, Marty? Correct,
Yeah.
Marty?
Yeah.
And so the hammock of the top guy's over the ascent stage hump, and the other astronaut was sleeping supposedly there in front of the door.
Yeah.
Exit door.
Well, he's on top of the engine, and that just shows the Apollo 6 1 with the fire, which I've discussed. We had all these wire bundles running across the floor. We still ended up with a block 2. We had 2 of them. This is just one of them. We had to get electrical power to the hand controllers, so they would run along the outer edges of the compartment. And then I'm in the way here.
And that's the green.
That's the green, and it runs up. There's a cable that'll run up the strut up to the couch, and then that
Right
goes
by me, right there.
and it goes to the 2 hand controllers, and the other side goes to the other hand controller.
Okay, that is interesting. How you get the power to the hand
And
controller.
there's 3 hand controllers. Now the couch is suspended out in the middle of the spacecraft. We had 4 vertical ones that you see there that are pointed out, and then you have 2 behind my head that are at about a 35-40 degree angle, and the impact when it hits the water is over on the very left side, so it comes down hanging down, and so the couch will go down and forward when they hit the impact water. And I just looked this up today, but they could see up to 12 to 40 Gs when they impact the water, depending on whether the wave, the size of how the wave action was.
Huh.
So if they slammed in the wave, it would get the other. Now these struts actually have a mechanical device in them. They're attenuators to help absorb some of that impact load. And so we'll go to the next picture here first. Okay, these are the
There we come to
There's-
the candy bracelets.
candy
kids.
bracelets. Okay, George Campbell was the engineer who designed this, and he told me what he had done. And let's go to the next one. And this is one ring right here. And let's go to the next one. And this shows a cross section of theoretically what he was using. Now he didn't use candy; he used stainless steel or soft steel. And what it is, you have the inner ring is the diameter of the inner tube, and then you have the outer ring is the outer tube, and they slide together into one. Now the diameter of the little rings is greater than the opening between those two rings. So when they put them in there, they start out round, and what they do is they force them in there to make them become oblong. And then drew this in. They had little cross threads in them, cuts in them to make them look like trank threads. And what would happen is as the two tubes slid apart, they would cause these things to start rolling, and that friction of that oval being moved around absorbed energy.
Huh.
And so they had a series.
That's what this is.
Yeah, and they had a series of those
bracelet of rings there inside the shock absorber.
Yeah. Now to keep it from happening, because there was no physical keeping these two tubes tied together like on a motorcycle front fork. It's the same principle basically, but they're tied so if your front wheel comes off, they extend out, they don't come apart. These will come apart. If you pull them on long enough, they will come apart. So let's go back. Let me see. I don't know if it's in the next one or not. No, they have to go back. There's straps that are tied to. Go back one more. Yeah, it shows up here. There's lanyards that are attached to the tubes, which operate a hook. And so when they get on the chutes, what they're supposed to do is pull those lanyards, and that disengages the hook, so allows the struts to stroke.
What a complexity of things that maybe you never even thought about before.
Now, the report is that throughout the whole Apollo program, they never saw those actually extend out at all. Now, if they landed on land, they would have had the.
So they didn't really see these extend out.
They didn't see it, because they were worried because on Apollo, on the last Skylab, they were coming up with a rescue mission, and they could bring back all the 3 astronauts that were on the space station. They would go up with 2 and come back with 5, and they would be positioned. They would lay on the floor underneath the couches, and they were worried at the beginning that says, hey, if these things stroke, they may crush the astronauts.
Right.
But then they found out that they did not stroke, so
beneath there.
We never used it, but.
All right, now you know why the candy rings are so important. The concept of them as for the shock.
Not many people knew that. This is looking for, if you're just laying on the couch and you looked up this is the commander's seat. If you're looking up, you can see the tunnel in the center there, and then you got your instrument panel left and right and center.
Commander on the left side.
Yeah, and the crew, I get mixed up with shuttles so much nowadays. The spacecraft commander would be in the center, and then the lunar module would be on the right-hand side. This is a Block 2. This is actually Apollo 14.
I was going to say, I guess that's 14 out
out
Kennedy
there.
Space Center.
You see the hatch open, and you can see the handholds. All the tape has been removed from this one here. And then this is Apollo 6 again, and I've showed this before on this program, but behind where my head is in a circle is the a panel that they had placed on there that had 3 test samples that when I go out to the pad on Apollo 6, you walk by it and everybody had to put their finger on one of these panels, and it made everybody, the designers who were the engineers of that, upset because it was a soft material and they would make an indentation from your finger, and they replaced it twice before they finally put a piece of plastic plate over the top of it.
What was the purpose of that?
Well, that was testing out new heat shields, and the furthest one on the left was the ablative material that's normally used, that we used on the
So
spacecraft
these
itself.
are test panels.
Yeah, let's move to the
on
next
Apollo
one.
6?
Apollo 6,
Okay.
because this is the first time we're supposed to be coming in
First
at
all-up test.
This is the first time we're supposed to be coming in at 17,000 plus miles an hour. So they wanted to test out 3 possible samples to look at in the future for being a heat shield. The one on the left, I'm in the way here. The one on the left is a blader material that was used normally, except it's one solid plate.
Yeah, that's right there.
Yeah, it's one solid plate, and it's had 1/2-inch holes, about 6 of them drilled in there in a pattern. The next one to it, that you see what it looks is tan, that was balsa wood.
Also wood.
Yeah.
Wow.
And the reason I asked, I said, why would you fly balsa wood? And they said, well, we heard that that's what the Russians were using on the Soyuz or on the Vostok. So we wanted to see if that's true. So they put balsa wood in it. And then the farthest one on the right was a grayish, gummy looking material. It had a little shine to it, and if you pushed your fingers on it, it would make an impression. And so it looked like the moon after about a week.
Everybody touched it.
Now this is the Apollo 6 up in Georgia. Now next one we'll blow it up a little bit. Okay, this is where the 3 panels, I drew a vertical blue line to show the separation. The one on the left seemed to did pretty good, but the balsa wood did not. You can see burn marks up above.
Middle.
Yeah, and then also the burn marks on the supports there. The other material did fairly well, but not as good as the blader. So anyway, they never did use that in real life. This is a lunar module stage that's being delivered in the Guppy.
LEM-3.
Yep.
So that would have been number 9, Apollo 9, right, Marty?
Yep.
LEM-3 there,
Yeah.
coming in there.
And then this is a boilerplate that was brought down, a high fidelity boilerplate. This is a service module that was brought into us prior to getting any flight hardware. This is a slaw being brought in. You can see the separation plane about a quarter of the way up.
We're going to get to Marty's question. What did they use to separate the 4 petals of this slaw that the lunar module was in?
Okay. This is a Kaplan tape that we used tons and tons of this for a lot of different issues and things, but it was actually the strangest thing we did was after Apollo 6, the slaw had one of the outer panels had blown off during the ascent, and they attributed it to moisture being trapped in the honeycomb. So they went in there and they drilled a series of holes. This doesn't make sense, but they drilled a series of holes every so many feet, all in a vertical line, spaced out equally around the circumference. And then one day while we're sitting there, somebody took a piece of litmus paper and says, well, I wonder what's inside that hole, if there's any moisture. Stuck it in there and it came out with tons of moisture exposed to it, supposedly. So they panicked, so they figured we need to cover those holes. So what we did, we took a roll of this Teflon tape, stretched it out to 25, 30 feet. We turned it upside down, laid it on the ground, and then we took parachute cord, two strips of parachute cord, and taped it to the backside. And then we took another layer of that tape and put it on top of it. And the only thing where it was going to be a hole, they didn't put the backing on it. So we would go in there and they would tape it up on there. And for final closeout, they would go in and they would grab those parachute cords and they would pull it down. That was supposed to keep the moisture out.
Wow. Did it?
I have no idea. We never had a problem after that, though. This is a hydroset. I think Marty may be aware of these. anything and everything that we ever lifted, whether it's GSE or flight hardware, had to have this in between the crane hook and the spacecraft. And this is one of the fancier ones we had that has a electronic readout. You'll see a load cell up the top. That's the blue that measures the amount of tension that's on the crane. And you have two handles. The handle on the left was a down, and the handle on the right was an up. And you had about 6 to 8 inches of motion that you could use, and each quick pull of that would raise or lower it by about a quarter of an inch.
Wow.
And then if you wanted to quick, if you held it down on the downside, it would just release completely. And somebody did that one day with one of the flight hardware. We were so lucky that it landed in the right spot. But we had different sizes. And this is the cameras that we used whenever we had a problem or we had a closeout. We called photographers. They would come out there, and this is the first thing that they pull out of their bag was a Polaroid camera. They take a bunch of pictures, and what they were doing was one is getting a proper light exposure, and also that they got the picture that we wanted. They would move it around, take pictures, and hand it to us. Is this what you wanted to see? If not, then we would do something else to get what we wanted to do, especially if we repaired something and we wanted to make documentation of it. And then they would, after they took the Polaroids, which they would give us if we wanted them, and then they would bring out the Hasselblads. And I think you talked about this the other day.
Yeah.
And right
500C Hasselblad there that Tom Usiak's very familiar with.
The right behind my head is the little clip that you would grab a hold to pull the metal piece out, slide out, so that you expose the film when you hit the shutter speed.
Yeah, and there's a crank on the other side to advance the.
And then there's also a crank on the back one, and they carried a series of them with them all the time. They had black and white, and they had color. They had a little bag, and then they would take one out, put it on there, take a few shots, write some numbers down, and then we could go and order that, and we would have it on our desk the next day, that picture. This is Apollo 8 and Apollo 9. This is Apollo 8 coming out of the chamber, and this is Apollo 9 getting ready to go into the high bay area. Wow. The service module was hoist laid down horizontally, and the command module was vertically.
So that's Apollo 9's service module then.
Yeah, and you see Apollo 8 does not have there's no high gain antenna, and there's also no nozzle.
Yeah, awesome. One-of-a-kind pictures as we're enjoying this conversation with Gary Allgire, talking about the minutia of his job to debunk the fact, how could you do all this and not go to the moon? Yeah. We got a little more time here to go with Gary, so go grab you a snack and come right back.
Now this is lowering it into the altitude chamber. This is probably could be 8 or 9, and that's me on the left over there watching it. We had some radiators that are around there that matched up to the two major radiators that are on the command module. Right here. I don't know how well this is going to show up.
Okay.
The white ones at the bottom are the radiators that are dedicated to the service module.
These are on, when you see models, that's the white there, the radiators to dispense.
There's 2 of them, and they cooled all the electronics in the service module and the tanks and so forth. And we used water glycol was the medium that was used. Water glycol is very hazardous. It's if you breathe it, it'll burn your lungs out, and it's very, very corrosive. Now the upper ones that are here that are still there's 6 of those. Those are smaller ones. There's 6. You'll rotate it around so you'll see that there's gaps between them.
Yeah.
Those are still attached to the service module and stay with the service module, but what they're there for is to cool all the electronics in the crew compartment of the command module.
All right.
Okay, so that's how we did that. And they also we had water glycol go through them.
Think of the space shuttle opening its doors and the radiators are on it to dispense. So
now for the shuttle, we used Freon because since this was only flown one time, we could afford the corrosion problem. And so, but with the shuttle, since it was going to be flown more than once, we had to have something different. And this is this is when we're going to put the command module, set it down onto the service module into the altitude chamber. Of course, the lid's off, and you can barely see the lid up there on the upper right hand side of the picture. That's the lid that they removed. And where we lift at is at the same attach points for the launch escape tower.
Okay.
And this is probably Apollo. It could be Apollo 1. This is the service module. It's in another stand right now for some checkout. But you can see the deck, and there's some standoffs. There's 6 standoffs that we sit on, with our little had round pads on them that meet round cutouts in the heat shield. And of the 6, only 3 were actually used to attach the 2 vehicles together. And this is what the cross section looks like of an attach point. You had this rod come down from the crew compartment into where you see down here. Get that. And there's a nut right here that we would torque to tighten it down to hold it in place. Then we would adjust the I don't know if I get over there far enough. It's I'm out of range. The pad, as you see it sitting there, it's that black looking device to the left of the shaft.
Yeah. Okay.
And then we torqued that bolt. We had to do a special torquing on it because of the criticality of it. And what we did is they had a strain gauge in the bolt itself, and we hooked up to an electrical box, and Downey would give us the actual readings that we would have to match. We would torque it till we got to those readings, and then that was torqued to the proper setting to hold it two together. And then once we got to the VAB and we set the launch escape tower on, then we had to go back in and redo them again because they would have loosened up because of the additional weight. This is the famous Apollo 8 umbilical that I had to give a tour to Rockwell Patron. And this is the cork installation that we had to put on. We did not finish this job until we got to the pad. That's how bad it was. And this is getting ready for an altitude run right here. I think this is 9. And then you have the 3 astronauts come in through a door up into about, you see the pad leader in the that's gutter went. It's in the yellow. If you go straight up from there, there's a door right there that goes out into the hallway.
Orange floor, it looks like. So people aren't familiar with the blue on the command module.
The ones that were going to the moon, they put aluminum mylar tape on there for reflection. To protect that, we had this blue covering tape on top of it. So when we got ready to put the boost protector cover on, wherever it on first, which was in the VAB, we had to peel that tape off and then expose that silver. And then we didn't pull the other tape off until actually we start putting the boost protective cover panel on.
Never seen that come up in any auctions or anything.
Yeah. We go back a little bit. Over here to the left, you'll see a gentleman in the blue.
Yeah, by Gunter Vince in the orange, and then.
Okay, we had a toolbox. The toolbox went wherever those Apollo spacecraft was. That toolbox went along with it, and that was all the tools that we could take into and work inside the spacecraft. You had to sign out for them, and then you had to log them back in. And so he's a monitor. You had to sign in with him also to go inside the spacecraft.
That's interesting. That's the toolbox there.
Yeah,
Looks just like
all snap-on tools.
Snap-on tools.
Oh yeah, they're nothing but the best.
Okay.
And this is Apollo 1. This is a stand that we put it onto after we come out of the chamber, where we put the high gain antenna on, and also we put the nozzle on for the. And then after that, we go and take it off of there, and we made it to the slaw. This is showing. This is Apollo 8 being lowered down onto the slaw. Again, you can see if you can blow it up a little bit.
Control area there.
Yeah, you can see that the umbilical, it hasn't got it's got some plastic paper film over it to protect it from the weather. You have the RCS engines down below it, and we have covers over the radiators to protect that
Yeah, you
paint.
see the radiator's real good there.
Yeah.
There's the bottom one, and then you got the
Top one up there.
ones are
And
tannish up
because
there.
and they were very delicate as far as the paint. And I got in trouble. Well, I didn't get in trouble, but I did do something out at there when Apollo 8 went out to the VAB. They closed the platforms around it, and there's a gap about 10 inches between the kick plate from the platform to the spacecraft. Well, they had put a rubber bumper, black rubber bumper on there to protect whoever touched the spacecraft. Well, unfortunately, when it touched the spacecraft, it left a black mark on that white paint. So I was standing there. This was on like third shift on a weekend I was working. And the tech came up to me and said, "Hey, we got a problem. Come and look at it." So he looked at it. He says, "What are we going to do?" I said, "Well, we can't have the black mark on there. That's bad because we got to go back and repaint it now." And he said, "What are we going to do?" I said, "Well, we can put some of this." We had some special vellum plastic that was slightly pink that was anti-static. We could wrap that around it and keep that from happening. But then we were rubbing against the paint. So I said, the other option is to cut them off. So that was the decision I made, cut them off. And the ops guy came over and said, "Did you say you did that?" I said, "Yeah, I gave the authorization." Didn't think nothing about it until Monday morning. I'm sitting on a desk and I get a phone call. And it was this guy from design engineering says, "I understand you're the person that authorized cutting these off. They're supposed to be there." I said, "Well, I know they're supposed to be there, but they interfere and they make marks on my radiators, and I cannot have that." And I said, "Not only do I not want them on there," I says, "wherever else you have them, in any of the bays or out at the pad, I want them removed." And they said, "Yes, sir."
All right.
I
We're
was,
joining us.
I was surprised.
That's a good story. You
Yeah,
finally
my
won
lead
one for
engineer,
you.
my lead
Yeah,
engineer.
Cliff Watson says commercial break. Put it on hot pause. We got
Yeah.
10 more minutes here or so to go
Okay. Yeah, we can put it
with
on
Gary,
pause.
but we're going to take our time. You're hearing a national treasure talk about all of the minutia of the Apollo command module and some of the lunar module here. As Gary worked with this, it's fascinating to see what he did as a job, and that's his point here, is to show all of the different things that had to have happened for us to go to the moon. And Marty Winkle, same way with Marty on the Grumman side, they had their own minutia of things to do there. Marty's talked about some of that on some of the Stay Curious shows. So let's soldier on here with the seats.
This will take, okay. These are the three hollow seats that the astronauts would use. The brown material is Teflon coated beta cloth. And Teflon is a fire resistant material. I didn't kind of realize that. In all your fire safety suits, or with NASCAR, when they wear those fireproof suits, that's got Teflon in it.
Okay.
And because it will not sustain itself except for Apollo 13. We'll talk about that on 13. But that's what they were used. They were very fragile. Normally, we after Apollo 7, we didn't put them in there anymore until the crew was getting ready for launch. That's when we would put the flight units in. And these are the foot pans and the calf pans, and I've circled one of them. This is one of the levers that they would pull so they could fold it back on itself.
Yeah, there's two of them, sir.
Yeah. There's another. The fancy one is this one, right? You had your hand on it.
Yeah, this one here.
Yeah. That's yeah.
And then one there.
Yeah, the fancy one. And anyway, they can fold those seats up, then they can unpin them from the frame, lower them, and stow them someplace underneath, and it gives them some more room, especially for in the center couch. That was removed quite a bit. In fact, you'll see in Apollo 9, there's a picture of.
They did not have the drawers going to space. This is not that was just what they set them on top of, I guess, and had all kinds of equipment under there to work on them.
Yeah. And then this is the rotation hand controller that the commander would have on his left arm. And then it's for, forward, backwards, sideways, up and down. And then on the hand controller, if they rotated it, that handle grabbed it, and if he rotated it 15 degrees to the left, that send a signal to ignite the launch escape tower. That was on board.
Oh.
We had a gentleman come down from JSC that got in there was explaining it to his other gentleman that came with him, and he actually did reached up there and did this, and light went off in the firing room, panicked everybody. This is at the pad, and he did not know that whether that launch escape tower was hooked up or not. If it had been hooked up, I was out there that day. It'd have killed all of us. It would have destroyed the whole pad if he'd have done that. He's the only NASA individual that I know of from JSC that has been permanently banned from coming to Kennedy Space Center.
Is that right?
Yeah.
They took care of him for
Yep.
actually doing.
Yeah.
But he was told that's what it would do, and he did that.
Well, he knew that's what it would do.
Oh,
Yeah, he was familiar with it,
wow.
and the buddy was not. So he just reached up there and says, "Yeah, this is you do this," and it sets off the launch escape tower. And this is a rotation hand controller for pitch, roll, and yaw. There's the commander has one on his right arm. The command module pilot has one on his right hand controller, but that's it. He doesn't have a translation hand controller.
Hmm.
And the little levers are lockout devices, so they can lock out the device if it's on, and they don't. So that if they bump into the handle, it won't cause the engines to fire, or the RCS engines to fire.
Okay.
And you had a trigger on the
Trigger. You see the black trigger
yeah,
handle
trigger
there.
up there.
Yeah.
That's what when he fired it.
Yeah, where all the games have come from
Yeah.
now. The video games
Yeah,
spun off all these type of devices.
Yeah, and he could extend the arm out, and he could adjust it to his preference, up and down the length of the couch. This is a docking probe. This is Apollo 14. That's me down on the lower left corner.
Okay.
This is
headset.
this is what we're mating with the lunar module. You can see the little bit of the drogue is inside, and then we extended the probe out, and then we just physically we can't actually do the actual what they would do in orbit. We couldn't hit the switch and say retract because there's 4 GN2 bottles in there, and so if we fired one of those GN2 bottles, then the probe has to come out, go back to Houston or Downey, California to totally rebuilt. This is coming out of the after altitude chamber, and sometimes we would go into this other stand right here, and the reason we did that on this particular one, next slide, is we were JSC asked us to remove the forward heat shield to look at either one time was for one of the mortars, the rigging of the mortar was correct, and another one was rigging of one of the lines on the parachutes, main
Mortar for the parachute.
Yeah, well, the mortar is a parachute. It comes out at 23,000 feet altitude, and it's what slows the spacecraft down, and then the pilot chutes will deploy at 10,000 feet and pull out the parachutes. This is Marty's Grumman, his lunar module. This is either going into the chamber or out of the chamber. I want to know. The landing gear is still not. That was the last thing I think you guys put on after it came out of the chamber.
Didn't look like the descent bells on it either.
No, it's there.
Okay.
You just don't see it in the picture. Again, another picture.
I
I think this is when they're
Not
putting.
familiar seeing the black there, Marty. Is that Inconel? Different looking, so dark and black
Yeah.
there.
And this is putting it into the slaw. It's held in by where the legs attach to the lunar module is also where we attach the to the slaw.
But did you take part of that, Marty?
No, I was down in pad. No,
Okay.
Yeah.
no, I was down in pad from Apollo 10 on, or
Yeah.
Apollo 9 on.
Yeah.
I was in the OSB, MSOB during Apollo 9. But
This is in the ONC building. This is putting the upper half on. You'll see one of the gray doors that Marty would go through.
Yeah,
That's an
you're
access
familiar
door.
with that great door, right,
Access door.
Marty?
Yes.
That's
We
how he-
also came back and we would put cookie cutters on there, which was a device that we would bolt to the outside. I don't know which positions they were. I think there was 2 of them. They would put an outside piece, and then you go inside and you put a core line matching inner piece, And if there was an emergency, we couldn't get everybody out through those two doors. So you could pull a lever. It was armed, and it would cut through the aluminum honeycomb and pop off. So that it gave them an extra escape route. Of course, we'll never fly that thing again.
Yeah, I think there was either six or eight cookie cutters,
Okay.
and they were just used during tanking of the lunar module.
Well, I thought we had them. We used them at the pad.
Yeah.
Huh?
Yeah, during tanking. That's all.
Yeah, during tanking. Okay.
So there you see the North American engineers with their emblem on the back. There, they're there because of the stage it's connected to, Marty. But my question to you is, what kind of handle was on that door for you to get in there? A wrench or a?
No, the door was always
It's always open.
Oh, it's always open.
Yeah, this is just for transportation.
Okay.
Okay, out to the pad.
Okay.
But yeah, and this is after we come out of the chamber, and after we've had this is Apollo 11. We had the nozzle put on and high gain antenna, and there we are lowering it onto the instrumentation unit of the Saturn V. You see a cord running up there, and you'll see a little gray area.
Yes.
That's a humidograph recorder. That records the humidity inside the slaw.
Oh, really?
We had one. Our branch chief that was his job. He was the father of that thing. He kept all of it. Had charts on there. And then it comes back to the VAB. This is again the flight verification vehicle.
Yeah,
I think that pretty well covers it.
And coming out to the pad on the crawler.
Yep. And
from
then
the VAB, gorgeous shot there.
And in the center there is the mobile support structure that was rolled up and give us access to the vehicle.
We've got a lot of people have hung with us on this long show, but very informative. John the Beagle Dads, he's on there. Steve Jokum says keep on going on there. Fox McLeod's been watching. Dave Stangy with his granddaughter Mia. She probably taking a nap now, but that's all right. Cliff Watson, we said hi to Dean Babcock and John FL 142, Steve Jokums, Tom Busiak, my daughter Jessie Q, and Mitch Rothman and Carlton Bailey enjoying today's show, Gary, just like we all have today. What a wealth of knowledge in minutia there as you are using this to talk about to the moon hoaxers.
Yeah.
How could you do all this?
Well, not only that, it's prior to launch, all the documentation that was generated up until that point, we're in the count, it's brought into a special room, and then all the subsystem managers from JSC come down, go into this room, as well as engineers from the plant in Downey, California, and they go through every one of those documents that we generated, line by line, to verify we did it correctly. And we would sit by our desk waiting for the infamous phone call that says, would you come down here and explain what you did on this step? And several times we got caught. We got especially caught on putting bolts in that had crimped inserts on them to lock them in place, and we eventually would wear that out. So we just threw it in there. So we'd have to go back and glue them in.
Would you circle here at the bottom of the?
That is the elevators. There's two elevators. There's a freight elevator and a personnel elevator. When you go out to the pad, you go around to the left-hand side of it, and there's a parking lot. And there's some trailers out there for the engineers and some support people. And you go into at the very bottom of ground level of the pad, and you go in there, and then you can go up stairways or you can take the elevator. But there's two levels in there where there's offices inside that building. And we had a desk in there when we were out at the pad all the time, so we could go and take a break too. But you come out of the smaller one, and then you go over to the left, and there you would get another elevator and go up to the top of the MLP, the mobile launch platform, and then you would walk back towards the mobile support structure where you would grab another elevator, and that would take you up to your level that you were working at.
Wow. Marty, you familiar with that?
Yeah, most of my work was going up to MSS. There's
Okay.
an elevator there, and there's also
Yeah, you could do that.
there's also stairs.
Fascinating stuff of something 50 years ago going to the moon with this mighty rocket.
Here is the one of the Apollo missions. You see that we've removed the blue tape. To the
Yeah.
left there is the white room, and above to white up above you is the boost protective cover that, and then we'll attach panels to that ring up the upper end of the boost protective cover. So the boost protector goes with the launch escape tower when they
Yep.
jettison it.
There's a picture of you with it.
Yeah, this is Apollo 17. It's hard to see the 17, but it was the last minute. This is the only one that we ever actually identified. I have other pictures.
They're Apollo 17 out of tape there.
Yeah, it's out of tape.
Yeah, right
It was
there.
a
That
last
box.
minute thing, because all the other pictures you have, you don't know which mission it is. You're just taken. So to the left in this picture is Jim. What's Jim's last name? He's an ops guy, and after this he went to California. To the right is golly, Mike Wiedemann.
Mike Wiedemann.
Yeah, he was Mike. He hired in about the same time I hired into NASA, and I used him. He was my contractor that I used or associated with most during the Apollo program.
Look here. Are you wearing a bolo?
Yeah,
You got a bolo on
yeah,
there.
it was in style back then.
That's right. You're
You-
styling that
you-
day with a polo shirt and a bolo
You
there,
can see
Gary.
you can see the struts from the launch escape tower,
Ah,
and then the room is actually attached to the launch escape tower to kind of give it a stability, and so it didn't move or separate from the command module.
oh, really?
Yeah.
That's interesting. And they
Yeah.
unseparate it, and
Yeah,
Away they go.
The clamps will
everyone
open up.
forgets about the cover that goes over the whole thing for
Yeah.
the launch escape tower is
Protects,
attached to.
yeah, the astronauts don't have any visibility. They just go for a ride.
Yeah. So that comes off.
Mhm.
Well, Gary, thank you so much. Set a
Yeah.
record for our longest show
Oh, my
ever.
gosh.
But I think I was entertained all the way, and those of you that stuck with us fine or paused it or coming back to it, you're gonna what a wealth of knowledge there. So thank you. We'll get the question from Marty here, the answer from the two of you. Go ahead, Marty.
Okay, first of all, Steve Holcomb, there are no pyrotechnics on the SLA. You don't want any pyros there, which can cause possible damage to the lunar module. There was a linear-shaped tube was inserted in the four seams of the SLA. A mild detonating fuse was used to expand the tubes, separating or opening up the panels, exposing the lunar module to space and to the command module.
The two door, when the panels came together, they formed a channel about like this, if you can look at that. And in that channel, they had this tube, a rubber tube is basically what it was. And then when you fired off the detonators, it put gas in there and expanded that tube. And the expansion of that tube sheared these two plates. And that's what caused them to come open.
Wow, just like Marty said there.
Yeah.
That's and you elaborated there. That's something I didn't know about at all. I knew that it wasn't pyrotechnics because of the damage that could be done there. Plus, shrapnel could have hit the command module too.
Yeah.
On there.
And originally they were stayed attached to the third stage, but on Apollo 7, one of them didn't come out all the way, and so they couldn't go in. And they had a truss, and they were the target, and they were supposed to go in and dock with it, and they couldn't do that because the panel was sitting up. Now there's pictures later where all four of them are open, but because the stage started spinning and its centrifugal force forced it open.
Oh,
And
okay.
there was cables, had a cable system there that would hold them in an open position. After Apollo 7, when they saw that, they just went ahead because they didn't want them going to the moon with the Saturn, the third stage. So that's why they didn't want them to come off. Well, they decided that we're going to have to take that risk. So after a 7, they all came off.
Okay.
And then they flew to the moon.
Well, Marty, I know you enjoyed it. Thank you for enjoying what you added there. We have an incredible show from Steve Jokums, Dean Babcock, great show. Mitch Rothman, great show. Thank you all for acknowledging that. the candy bracelets were used in the shock absorber, not the candy themselves, but the concept in the shock absorbers on the Apollo chairs that I never knew till you told me, a year ago or so, that they were suspended in midair, basically.
Yeah, we're
in there.
spinning
So,
midair.
Marty, thanks for a great job today. Gary, thank you,
You're
as always, with your expertise, giving our viewers something that they don't get anywhere else, the true story from space workers who the American Space Museum consider national treasures for what you've done, take us to the moon, and also build the incredible International Space Station. So we'll have you back in a week or so, or after
Okay.
the first of the
Yeah,
year.
first year probably.
And he's got a great show he wants to do on Apollo 13 that bring up some things that people don't seem to talk about. Gary's always looking for things to share with our wonderful, intelligent group of Stay Curious followers there. So tomorrow and Friday, we're going to look at some Christmas things in space. And Friday will be our last day at the museum until the following Thursday, as we're going to take a full 4 days off and be open Friday and Saturday. I'll do a Friday show on the Star of Bethlehem after the Christmas celebration, and then we'll take off again Monday on New Year's, Monday, Tuesday, and Wednesday, and come back. And we deserve the break. We've had a rough year in many ways, and but we've always enjoyed you being part of our family here. So until tomorrow, and on behalf of the American Space Museum, I'm Mark Marquette saying we can't wait to see you in our museum to bridge the space between us.